Alright, in this video we're going to be calculating the empirical formula and then the molecular formula of a compound that has the following composition. So in this case, you are actually told you have 76.54% carbon, 12.13% hydrogen, and then 11.33% oxygen, and those are the three elements that makes up that compound. And we first find the empirical formula, and then after finding the empirical formula there is one more step that we have to go through to get the molecular formula. All right, so um, there are going to be times when you're going to be actually given grams of those elements that makes up the compound, but then sometimes they are going to be giving you the percentages. And if they do give you the percentages, the first thing you want to make sure you add up all the percentages and see if it's going to be a total of 100. And if that's the case, like in this case, when I add those up, it comes out to be 100. And if they do come out to be 100, you can take those percentages as your grams. So what I really have here is 76.54 grams of oxygen. Okay, and then I can write down for the hydrogen as well. So I got 12.13 grams of hydrogen, and then I have 11.33 grams of oxygen. Okay, so you can do so only when their percentages adds up to 100. Suppose their percentages does not add up to 100, so that's very likely there is another element that question has told you but did not give you the percentage. So you can subtract that to the total percentage you get from 100 to get the percentage of the last element that they did not give you. But for the most part, they will give you the percentages that adds up to 100. Okay, well, like I said, the very first step is going to be finding the moles of these compounds, or these elements rather. So let's find the moles for this carbon. So we're starting out with the grams. So to get to moles of carbon, I would have to use the atomic mass. So I would put grams of carbon on the bottom and moles of the carbon on the top, and then fill in the numbers. One goes with the moles, and with the grams is going to be the atomic mass, which is 12.01, and then just go and figure out what the mole is going to be here. So we have 76.54 divided by 12.01, and that comes out to be 6.37 moles of carbon. Okay, and here the grams of carbon cancels out. All right, we're going to have to do the same thing for the other two atoms. So now let's find the moles of hydrogen. So I will say 1 mole of hydrogen on the top, and then what's the atomic mass of hydrogen? Well, it's 1.008 grams of hydrogen. So grams cancels out here. So it's going to be 12.13 divided by 1.008, which is still going to be roughly close to 12, but it's important when you're doing these empirical formulas and molecular formulas to use at least 2 decimal places of the molar masses and write the exact numbers you get. So it's going to be 12.03 moles of hydrogen. Okay, so now once you have the moles of carbon and the hydrogen, we're going to do the same thing with the oxygen now. And what's the atomic mass of oxygen? The atomic mass of oxygen is going to be 15.99. So 1 mole of oxygen is going to be 15.99 grams of oxygen. And then do the math here, and let's see what that comes out to be. So we got 11.33 divided by 15.99. And that's going to be 0.709 moles of oxygen. Okay, so once you calculate the moles of all the elements that makes up the compound, the next step is going to be dividing all of them by the lowest mole, like we have done in the another problem. So the lowest mole in this case is going to be 0.709, so I want to go ahead and divide all of those by 0.709. So 0.709 here, and then we have 0.709 here, and the same story, 0.709 here. So let's see what that comes out to be now. So 6.37 divided by 0.709 is going to be 8.98. So 8.98 moles of carbon, and then we'll do 12.03 divided by 0.709, and that's all is going to be 16.97 moles of hydrogen, and this is going to be 1 mole of oxygen. So now, when we look at these moles, they're actually very close to a whole number. This 8.98, you can almost take that as 9 moles of carbon. The 16.97 is almost 17 moles of hydrogen. And then this is going to be 1 mole of oxygen. So your empirical formula becomes C9H17O1. So that's going to be your empirical formula. Okay, so if they were not close to a whole number, then you would have to multiply with the smallest integer to get to a whole number. But in this case, we didn't have to do that step. They were actually already in a whole number. So now the next thing we have to do is find the molecular formula. So to find the molecular formula, you need two things. We need the molar mass, and the molar mass for the most part will be given in the problem. So the molar mass for this compound, if we go back, is given to be 282.4. Okay, so that's going to be 282.4 grams per mole. And then in addition to that, we also need empirical formula mass. The empirical formula mass is going to be coming from the empirical formula you had just calculated. So I got 9 carbons there. So it's going to be 12.01 times 9. Plus we have 17 hydrogens, and that's going to be times 1.008, and then plus 15.99. So when we do this math, so we got 12.01 times 9, and then 17 times 1.008, plus 15.99, and that's going to be 141.2. So this comes out to be 141.2 grams per mole for the empirical formula mass. So once you have the empirical formula mass, you want to go ahead and divide the molar mass by the empirical formula mass to find the ratio there. So I would do 282.4 divided by 141.2, and that actually comes out to be 2. So what that really means, the empirical formula that you have calculated, which was C9H17O, we want to multiply these subscripts by 2 now to get the molecular formula. So your molecular formula is going to be C18H34O2. Alright, so this is going to be your molecular formula. Okay, so like I said, there is only one step to go to molecular formula. Once you have the empirical formula in, you have to find the formula mass for the empirical formula, and the molar mass will be given in the question. You divide those, find the ratio, and whatever number you get, you're going to be multiplying that number with the subscripts. Alright, so hopefully this video was helpful. If you have any questions, please leave the comments in the section below.